If a body is moving, we want to stop it. That is change of motion. If a body is at rest, we want that it should move. That is change in the condition of motion. And what is required to change the condition of motion is force. What is force? Force is the action of pushing something. Push is in general language. Force is in the language of physics. So it is force which changes the condition of motion, and if a body is at rest, it is force which brings it to motion. So when we study laws which are governing force related to motion, these are known as laws of motion. Okay, so Newton made these laws, and there are 3 laws. First is law of inertia, that was basically made by Galileo, which was adopted by Newton. Law of inertia, you all know, a body at rest will remain at rest, and a body in motion will remain in motion unless an additional external force is applied on it. Now, this law has 2 parts, that is inertia of rest and inertia of motion. Now, what is the meaning of inertia? Inertia is an inherent property of any body. Inherent property means what? We don't have to create it. It is already there. And that inherent property is about what? About its inability to change its condition of motion by itself. Any object which is moving and it wants to stop, it cannot stop by itself. It needs help of some external agency or external force. So the inability to change its own condition, a body at rest can never move, a body in motion can never stop. This property is known as its inertia. Inertness, nothing, able to do nothing, that is inertia. Okay, now in this law, first law, what is speciality of the first law? What does it tell us? So please remember what is told by first law. It tells us the definition of force. What does it tell? Definition. And what is that definition? Force is something which can change the condition of motion. What is force? Force is something which can change. Yeah. So this definition is created by which law? First law. Right? You know about inertia, and you know the examples of inertia. Inertia of motion, inertia of rest. Both examples are there when a bus starts and brakes are applied to a bus. When the bus starts, which inertia is applied? Rest or motion? Okay, please remember, whatever is the earlier condition before our action, that will have the title of inertia. The bus was at rest and then started moving. So what was the initial condition? Rest. So inertia of rest. A bus is moving, brake is applied, and the person moves forward. Inertia of motion. Because it was in motion, then something was done on it. So this is all about inertia, and you all know that. Okay. Then how can we measure inertia? Yes? How can we measure inertia? Answer is mass of a body is the measurement of its inertia. Very simple. So inertia of one body is 1 kg, one body is 2 kg, so inertia of 2 kg is more, that's all. So measurement of inertia in linear motion is mass, remember it. In rotational motion it will be different, and there we will call it moment of inertia, I. Right? In linear motion it is only mass. Now, this is all about inertia. That is first law, which tells us definition. Now we go to the second law. Second law, first law, inertia. And what does it give us? Definition. The second law, what does it say? It say, yes, anybody? Force is equal to ma. No, what you are telling? Yes. The law is rate of change of momentum and the force applied are proportionate. F is equal to ma is not the law. That is deduction from the law, a calculation of force. So what is the force? What is the second law? Second law is force and rate of change of momentum. Force is proportionate to rate of change of momentum, or change in momentum divided by delta P by delta T. Rate of change of momentum is proportionate to force. This is the law. And with this law, you have done the derivation. And what is that derivation? The force is calculated by acceleration multiplied by mass. This is acceleration. This has come from the second law. In this we are using the word momentum. Now what is this momentum? Any definition of momentum? That is calculation of momentum. Mass into acceleration is calculation. What is definition? There is a difference in calculation and definition. That definition shows the properties. We decide the definition by properties, and when we have to do the calculation, then we tell the formula that P is equal to m into V. Okay? Anyway, momentum is a physical quantity which is contained by a moving object. Is a physical quantity which does not vary during motion of an object. This is a definition of momentum. Again, what is this? A physical property of the object which do not vary during. Yes. Now in this, in modern physics we study even matter word has been removed. Physical momentum is a physical quantity of motional invariance. Motional means during motion, invariance means do not change. The light of the sun, light from the sun moves towards earth. There is a motion of the light. So during the motion it has momentum. So the light, which is a wave, even that carries momentum, because anything which moves has momentum. And you have studied in class 12 modern physics that what is the formula for momentum of a photon, light, in terms of photon, momentum carried by it. So now momentum definition has changed, but for this purpose, for classical physics, for mechanics, momentum is property of the material which do not change during motion. Okay? In other words, we can say it is effect of motion. If a body is in motion, then it has an effect. That effect is known as momentum, and that momentum is how much? It is calculated as mass into velocity. So this effect, because of momentum, what a body can do? A body can apply force because of momentum. And then we say the force is proportionate to rate of change of momentum. So this is momentum, mass into velocity. Many questions are asked from momentum, which makes it very important. That is, momentum of a system. Momentum of a system do not change unless an external force is applied on it. Now understand, if a body is moving if I shoot a bullet towards the wall, it has got a mass, it has got a velocity, therefore it has momentum. Now it strikes the wall. What happens to its velocity? It becomes 0. Now what is its momentum? M into V, 0. So can we say that momentum is conserved? When a bullet strikes a wall, is the momentum conserved? Yes or no?
Yes,
Conserved?
sir.
Okay, its velocity here was m into v, then it has become m into 0. How it is conserved, you say? Explain. Pardon? Transfer to? Okay. That means you can calculate velocity of the wall? No, we are talking about conservation of momentum. Where has that momentum gone?
Wall is bigger mass.
Wall?
Bigger mass.
Tell clearly, what are you saying?
The wall is a bigger mass. So
Wall is a bigger mass, so its velocity will be very small.
it won't move at all. Since it is so bigger mass, it won't move at all.
It won't,
Move at all.
means velocity will be 0. Then how much is the momentum of the wall? 0. Anyway, this is a quiz question. The wall will have no velocity at all. That is sure. Then where has the momentum gone? Pardon? Anybody? Okay, you are not sure about it. Anyway, this example I gave you to give one explanation, and that explanation is that when we say momentum is conserved, please remember, momentum of a single body is not conserved. Momentum of a system is conserved. And this is generally students do not remember. Whose momentum is conserved? System. So we have to think, when a bullet is hitting a wall, what are the things involved? You are thinking two things, and that's very correct. Bullet and the wall. But unfortunately, wall has no velocity. Then, are you forgetting anything? Oh, no. No gun. Bullet is here. It has left the gun. Here there is a bullet having mass m, velocity v. It goes there, strike there. Okay. Anyway, let's close it. When the bullet strikes a wall, the other thing involved is air particles. And some particles, splinters, the cement particles. When the bullet hits there, what happens to those small particles? Cement particles move out. They certainly get velocity. If a bullet hits a wall, some of the cement particles here, there will be a hole. What will happen to those particles? They will jump out. Then there will be air. When you compress these two things like this, what happens to the air in between? It goes out. There is a water before you, and you put your foot on this like this. What happens to the water? Yes, splash. Similarly, air splash. When a bullet hits a wall, we don't see it, so we don't count it. But it does splash. So, mass of all the air and speed with which it splashes out, m into v. Small cement particles coming from the wall, they are having mass and they have certain velocity of moving out. Calculate that mv, that will be exactly equal to mv of the bullet. So, how do we calculate it? How do we make the equation? Our equation is always left hand before the incident is equal to right hand after the incident. Before the incident, now make a family. Who is going to participate in it? Bullet, cement particles, air. Here, before the incident, which particle has the momentum? Bullet. For cement particle, 0. For air particle, 0. After the incident, air particles have momentum, cement particle have momentum, bullet is 0, and it is exactly equal. So please note, the conservation of momentum is for systems, not for a single particle. Remember that. So don't get confused when such question, any similar questions can be asked in a competitive examination, and you must know that this is for the system and not for the single particle. Okay, that is about momentum. Rate of change of momentum is this. So we can say F is equal to momentum final, momentum initial divided by time taken. This. Okay, this is second law about momentum. There is one other quantity we are supposed to study, and that is time multiplied by force. Time multiplied by force. What is that quantity? Very good. What is impulse? Definition. That is calculation. Okay. Impulse is effect of the force which is applied for a very short time. Force applied for a very short time. It has an effect, and that effect is calculated. How? Force into time. The only thing is that this force is not uniform. So we cannot take one value of force multiplied by time. We can't do that. You see, this force is like what? On the road, a motorcycle is coming here. You have not seen it. You just put your foot forward. At that moment, that motorcycle has approached. And the wheel will just cross your foot and move. You experience a force on your foot for a very, very small time. Right? Okay. But that force does not damage you much. Why? Because the time was very short. That force is known as impulsive force. Okay. The impulsive force is a variable force, and how is the variation? Impulsive force or impulse. Initially, the force was 0 when the motorcycle went over our foot. Suddenly the force increased at this time, and it becomes maximum, and then it comes down. So this is a very small time, delta t, 0.1 second. Within 1.1 second it crossed over. But during that 0.1 second, all the time force was not equal. It went up. Here the force is less, more, less, 0. This is the force. So variable force multiplied by time, this. Such forces which are applied for a very small time are impulsive forces. Another example, please remember. Catching the, yes, very good. Another is just having a nail and do the hammering. That is again an impulsive force wherever small time is there. Now in this, the force applied multiplied by time. Which force we take here? Because the force is always changing, so we cannot do that. So we make a formula in integration like this. This total area gives us what? Force multiplied by delta t. But what value of force? The value of force is changing. It is a function of time. So we will do force multiplied by a very small time, dt. F into dt. This is dt. A very small time approaching 0, and this is force. Force multiplied by dt, and for this, integrate all of them. Integrate all of them. And this becomes the impulse. So impulse is integration of F dt. In mathematics, in graphical formula, the area under force time graph. force time graph, area under this is impulse. This is calculation. And now there is another calculation. That calculation is what? Force into time. Force into time. What is that equal to? Yes, change in momentum. Please remember this relation. This is going to solve many problems. Change in relation is, change in momentum is impulse, which is force into time. And if you divide this I with time, what do you get? I. Divide it with time. Force. And how do you get I? Change in momentum. This is what you are going to apply in the numericals of catching a ball. Some time is taken, and this explains so many phenomena that when we jump in a swimming pool, we don't get damaged, and if there is no water in the swimming pool, there is accident, we get damaged. Why it happens? Make it very minutely. Why do we get damaged? Because of the force applied on our body. Effect of the force is very large. When we strike a hard floor, the effect of force is very large. What is the effect of force? That is change in momentum. Right. The force applied is very, very large. Why it is very large? Okay. See the action minutely. When our body is moving, it has certain velocity. It has certain moment. What is that momentum? Mass into velocity. When it strikes the floor, that velocity becomes 0. M into 0. That becomes 0. There is a change in momentum. mv to 0. There is a change in momentum. What is that change in momentum? I. Now, how much force is applied on my body? It depends upon what? Time. When we strike the floor, the time for change of velocity is 0.1 second. When we go through water, we strike the top surface of the water, enter the water and go down. It takes 2 seconds. 0.1 second to 2 seconds, 20 times. If time increases 20 times, what will happen to force? Decrease by 20 times. Right? And you save your body. The same thing happens when we talk about high jump, low jump, and having the sand pits and having the cushions, everything. In everything, what is happening? Change in momentum. In everything, what we are controlling? The time. Understand? Okay. Now, take it the other way. I have got this nail, I put it here, and I ask him, please go in. It doesn't go. And I put a hammer on it. Now I say, you go in. Even it does not go. What I have to do? Strike. When I strike, this is mass m. It has got velocity v. When it strikes the nail, what happens to velocity? Become 0. There is a change in momentum. That gives us impulse. And the time. Have we given a long time of strike? No. It is instantaneous. In for how much time it was in contact? Cut. That is 0.1 second. Very small time. So what happens to force? Very large force. So this is example when we are reducing time. And when we are increasing time, that cricket ball, jumping in the water, all in those examples, what we are doing? Increasing time, reducing force. In case of hammer, we are reducing time, increasing force. Yeah. So it comes to our advantage. Whatever we want, if we want large forces, we will reduce the time, make the impact. And if we want to decrease the forces in natural processes, we increase the time. And there are many examples of this. In every example, there is only one answer. We are increasing the time of impulse. In the crockery, we are putting grass around the glasses, around the cup, and then pack it. Paper around the cup and pack it so that it doesn't break. Why? Same thing. When they strike each other, they strike like this. It has certain velocity. Strike, velocity becomes 0. And the time is almost 0 for change of velocity. If the time is 0, the force is very large. It will break. But if you put paper in between, first it has to press paper and then it will strike. The time has increased. The force has decreased. So for momentum, everything is like that. Okay. So this is change in momentum, impulsive forces. Now we come to the third law. Third law. Yes, what do you know about third law? Every action has
equal and opposite reactions.
That is right, but we don't apply it that way. Every action has a reaction. This is the basic law which was promulgated by Newton. But later it was difficult for us to understand it because we applied in a very confusing way. So we made it clarified that if there is an interaction between two bodies, how many bodies? There has to be interaction between two bodies, then force applied by one on the other is equal and opposite to the force applied by second on the first as a reaction. This is detailed and this is what we study. The two bodies, if A is applying A, B, C, these three are in contact. If A is applying force on B, then reaction has to be done by B on A, not on C. So sometimes we get confused about it, that if I am pushing the car is pushing me back, then why the car should move? I am pushing a car and car is pushing back me, then why the car should move? There are two equal and opposite forces. Okay, we will come to that example later. First, action-reaction pair. In third law, what we should be clear about is action-reaction pair. So in any action, you must understand and figure out who are the partners who are taking part in this action-reaction pairs. Right? So that is one thing. Force applied by one is equal to reaction by the other. That is true. That will always be there. But we must understand that it is only between action-reaction pairs. That is one thing. Other thing, that is third law. And how you will start it? In interaction. In interaction between two bodies. Force applied by one is equal and opposite first on second, second on first, between two bodies only. Okay, this is the third law. This is all about three laws. Now, next thing we come to application of forces. Application. For application of forces, one thing more. What is told to us by first law? Definition of force. What is given by second law? Calculation of force. What is given by second law? Calculation. And what is that calculation? F is equal to mass into acceleration. That is calculation. Okay. Third law gives us characteristic of the force. Pardon? What did you say? Anybody? Third law gives us what? Okay. Third law gives us the characteristic of the force. What is that characteristic? That force is always equal and opposite to the action applied on it. Okay. So now we come to the application of force. When we apply force on a body, then a body should move. Should it? And for that we understand that if I am pressing this body downward, it is not moving. Why it is not moving? Yeah, because my force is getting cancelled. How a force can be cancelled? Okay, so we understand we have different adjectives before the force. And one such adjective is the net force. There are many adjectives. First we will study net force. Any body may be under effect of many forces at any given moment. If there is one body here, somebody, or you can say earth is applying a force downward. I am applying a force upward. So there are two forces acting on this body. It is possible that one body is under so many forces applied to each other. Force is a vector quantity. It will have magnitude, it will have direction, like that. Those are all the forces acting on a body, different forces. Now, a body will move or not move. It depends whether, what is the value of net force. What is net force? Addition of all the forces. The forces which are in opposite direction, we will give it negative sign. In one direction, we will give it positive sign. If there is net force, then the body will move. If there is a net force, the body will move. There is another name of net force that we call unbalanced force. If this here, it is not moving, even though earth is pulling it downward, why it is not moving? Because that force is cancelled by force applied by my hand. And what is the net force? Okay, the force of the earth, is it now balanced or unbalanced? Balanced. Balanced by my force. And now? Yes, unbalanced. Unbalanced force create motion. Very simple. And that motion under the force will always have acceleration. Mind it. A body with uniform velocity, no force. What should be there? Acceleration. Correct? So a body moving, is it having force? Depends whether it has acceleration or it is simply moving with the same velocity. If it is moving with the same velocity, no force. So it has to have acceleration, and that is F is equal to ma. This we have done. And this force, this should be unbalanced force or it should be net force. So this is how the body moves. Other thing, internal force and external force. In a system of particles, so many things are there. Any member in that body is applying force another member of that body. That is known as internal force. In a system of force, one member applying force on the other. That is internal force. I am sitting in a car. My body, car's body, car seat, wheel, steering, everything is member of a system. Right? I am sitting on the back seat and I push the front seat. With lot of force, the car doesn't move. So how much force I am applying, car doesn't move. You can give me many reasons how my force is being balanced. Right? Maybe But what I will say, because I am member of that system and I am applying force on another member of the system, the car doesn't move. So I will say it is an internal force. What type of force?
Internal force.
An internal force never moves a body. Internal force never moves a body. My friend comes outside, he is not member of this system. He stands on the ground, he pushes the car moves. His force is what? External force. He is not member of the body. Understand? So for any motion, what do we need? Yes, external force. External for motion. So for motion, what do we need? External force. For motion, what do we need? Unbalanced force. Unbalanced or net force, and that force should be external. Then only a body will move. Clear? Okay. This is about definitions. If something is asked about the different adjectives related to force. Now, we have to study about the forces practically in our life. Where are these forces? What are their kinds and how do they behave? In this, in our syllabus, there are many forces, rather I should say all of the forces. One force you have to study is force of friction. The other one you have to study is force applied by a spring. Other one is force applied due to mass, which you call gravity. Another force due to electric charge, that is electrostatic force. And there is another force which also you study class 12 later, that is electromagnetic is in one category. Yes, nuclear. What is that? Nuclear. So these are the forces. All the forces you have to study in class 11th and 12th together in that course. So we, in this particular portion, because gravitational force, electrostatic force need lot of study, that we have kept a separate chapter. In this chapter, we will study the minor forces, which are forces of friction and the forces due to spring. So let us start with force of friction. Force of friction. This is a force between two particles. Force of attraction. They want to just take hold of each other and they don't want to leave. What type of force it is? There are basically four types of forces. That is electrical and gravitational, strong nuclear and weak nuclear. Only four forces. So friction is which category? Friction has to be one of these four. Anybody? Friction is not a different force. It is one of these four. Okay, please remember, friction is electrical force. What type of force? Electrical force. Because you are studying electrostatics, we can discuss it. There is an atom, the number of positive charges and negative charges are equal. Right? Okay. Now, if I take one electron out, what is the net charge? Positive. This electron goes to this body. What is its net charge? Negative. They come together and stick together. Because of which force? Electrostatic force, Coulomb's force. Now I want to move it. I can't, because there is a force between them. I say there is a lot of friction between the two. So, which type of force friction is? Please remember. Understand? And there is another example of it. Very good example. What I told you, the electron is removed. If these are the electrons, how can I remove one electron? Answer is, put this thing on it. Is the electron removed? No. Push it this way, this. Now there is entanglement and it is removed. So what is required to remove that electron? Motion. If there is no motion, it is not removed. there is no force. I change the language. If there is no motion, there is no friction. Correct? Now you understand why without motion there is no friction? So the friction takes birth. Friction starts only when there is an attempt to move. If there is no attempt to move, there is no friction. Okay, this, I rub on it this way, there is friction. If I put it like this and take it up, put it like this, take it up, is there any friction force? No. So friction has to be there when there is a relative motion or there is attempt of relative motion. When a body tends to move, we say tends to move. It has not moved. But the moment it tries to move, the first thing what it has to do to break one electron. And we don't even see it. At that moment, the force, electrostatic force, pull it back. The friction start. I put it here. Apply the force. 1 Newton, it has not moved. 2 Newton, not moved. 3 Newton, it moves. Why it has not moved in 1? I am applying 1 force and it is not moving. That means my force is being balanced. Who is balancing it? There has to be a force opposite it. We are not seeing it, so we say it is force of friction, which is balancing it. And we know why it is there. Where it is? Between the two surfaces. If I want to pull it up, no problem, only mg, no frictional force. And now you can understand it is because of that action, horizontal action. So friction is basically electrostatic force. What does a friction do? Friction always opposes the motion or tendency of motion. Motion or intention of motion. How it opposes the intention of motion or the motion? By applying a force. Okay, in which direction it applies the force? Opposite direction of? Opposite direction of? No. Yes, this is a mistake what students do, and this is something which is important asked in the questions. The direction of friction. Please remember, it is not opposite to the force applied. No, it is opposite to intention of motion. Opposite to intention of motion. There is a road roller here. I pull it in this direction. Will the friction be in this direction? No. In which direction the roller will move? In this direction. The friction will be in this direction. So the friction is always opposing intention of motion, and there is a very good example of it. See it? Yes. Here is a wall. I put a box here and I apply a force here. This is being pushed down, pulled down by what? mg. It does not come down. Why it does not come down? There is a force here in this direction. Why it should not come down? This force is in this direction. It cannot cancel this. Why it is not falling down? We know it is not falling down, therefore we declare there has to be a force which is balancing it, opposite and equal. What is that force? Very good. You can now make out friction. What should be the direction of that friction? Should it be in this direction? 1, 2, 3, 4. Which direction it should be? 3. How its direction is 3? How can you make out? Applied force is in which direction? This. Opposite to applied force is this. The friction should be opposite to applied force? No. What is the intention of this body? Where does it want to go? Therefore, friction will be upward. So it is always opposite to the intention of motion, not to the applied force. Okay. But I can correct you. Why only F is the applied force? Mg is also applied force. If you take mg as applied force, then friction is opposite to that applied force. So a body may have more than one forces. It can confuse you which is the applied force responsible for motion. But if you find out the intention of motion, where the body is just going, you can always find out that friction is opposite to that intention. So note it down. Direction of friction is opposite to intention of motion at the point of contact. At the point of contact. This is necessary. Other rule is the friction is always tangential to the surface.